Today we're going to be working on applications of trig functions. Pause your video now and have a read of this question. We're going to need to create an equation for this model, but first we're going to graph it just to see what it would look like. Okay, so we know at 2 a.m. it reaches high tide. So that means we should have a point at 2:06. And we know that low tide is 6 hours later, so at 8 a.m. or 8 hours past midnight, we're going to be at 2 meters. And then of course, because it is cyclical, tides are cyclical, and the period is going to be 12 hours, we know at 2 p.m. or 14 hours past midnight, we're going to get back to high tide, so that'll be 14:06. And the point of inflection, which could be useful later, has got to be exactly halfway between the max and min, both vertically and horizontally, so we're going to have the point 5.4. So at 5 a.m. it will be at 4 meters above the ocean floor. So now we have enough points to graph this thing. So sketch your curve, and it's going to look something like that. Okay, now that we have the picture in front of us, we're going to need to come up with an equation. All right, so we know that the y-intercept isn't a max or min, which would lend itself to cosine, and it's not a point of inflection, which would lend itself to sine, so I can really choose whichever one I want. I'm going to use cosine this time. So y equal a cosine bx plus c plus d. We know the mean line, or principal axis, is y equal 4 because it goes right through that point of inflection, which is 5.4. So that means we had a vertical translation up 4. We know the amplitude of this thing is 2, because from that mean line it goes up 2 to get to the high tide and down 2 to get to the low tide. So we know that we have a 2 there. And we know the period of this thing is always 2 pi divided by that horizontal compression, which leads us to b being equal to 2 pi over the period. Well, the period in this particular problem is 12 hours. Therefore, b is going to have to be pi 6. So we can come up here and put a pi 6. And all we have left to do now is figure out what that phase shift is. Well, cosine without a phase shift is going to have a max at the y-intercept, but it doesn't. So we must have taken that y-intercept and moved it 2 to the right. So we're going to put in an x minus 2, so the phase shift is 2 to the right. You could have chosen to do a sine curve instead, and everything would have been exactly the same except for that phase shift. So to figure out what the phase shift is, we know that sine curve usually starts at a point of inflection increasing. And so if we look at that point of inflection and where it starts to increase is right there, so that would have been 2 to the left. So our phase shift would have been 2 to the left, and that's what your sine curve would have looked like. Now the question said it's dangerous to be in the harbor when that tide is 3.5, when the water is 3.5 meters above the seafloor or less. Let's see when that would be. From looking at my graph, it looks to be about right there, and again it happens about right there. That would appear to be somewhere about 5:30, and that would appear to be somewhere around 10:30. So somewhere between 5:30 in the morning and 10:30 in the morning does not appear to be safe. But we're going to go ahead and solve this algebraically now. To solve this algebraically, we want to know when it is that 2 cosine pi 6 times x minus 2 plus 4 is actually under 3.5. In order to do that, we're going to find when 2 cos pi 6 x minus 2 plus 4 is equal to 3.5. So we will subtract 4 from both sides. Then we will divide both sides by 2. Then we'll take cos inverse of both sides. Now I know the cosine is negative here in the second quadrant, and also in the third quadrant. Negative 1 and 4 becomes your hypotenuse. And so now I can go to my calculator, set in radians mode, and it's going to tell me this first angle is, let's see, 1.82, and then taking that 1.82 and subtracting it from 2 pi is how I'm going to get this third quadrant angle. And so when I do 2 pi minus 1.82, I get 4.46. And so now, I'll make that approximate, and now if I multiply both sides by 6 over pi, and then add 2 to both sides, I'm going to get 5.48 hours after midnight and 10.52 hours after midnight. So that tells me when the water is 3.5 meters above the ocean floor. I wanted to know when it is less than 3.5 meters above the ocean floor, and I can see from looking at my graph that happens between those two values. So that's going to be between 5.48 a.m. and 10.52 a.m. Sir, nobody says 5.48 a.m. or 10.52 a.m. Yes, that is true. Okay, so what we're going to do then, we'll erase all this. We have a little bit more room. And we'll say, okay, 0.48 a.m. So we're talking about 0.48 of an hour. So 0.48 times 60. And that is going to give me 28.8 minutes. So we can say approximately 5:29. Similarly, we do the same thing with 10.52, and that gives me approximately 10:31. So your answer then is it's unsafe between 5:29 a.m. and 10:31 a.m. And since the question asked throughout the day, and we know that the period is 12 hours, we know that the same thing is going to be true from 5:29 p.m. to 10:31 p.m. And this seems like a lot of work to get what we basically got from the graph to be about 5:30 to 10:30. I do want to show you one more approach, though, that you might prefer. Hard to know. So let's go through and solve this equation again, as if there's only one solution we're concerned about. So everything else is going to go exactly the same right down till we get to this point, and we normally look for both the angles between 0 and 2 pi. This time we're just going to look for the 1, and it's going to say 1.82 is what the calculator is going to give us, pi 6 x minus 2. Then I'm going to multiply by 6 over pi and add 2, and that's going to give me 5.48. And that is hours after midnight is when we're going to be at 3.5 meters. And then I'm going to convert that into a time, 5 hours and 29 minutes after midnight is when we first reach 3.5. And then I'm going to see here, from looking at this graph, low tide, which is at 8 a.m. 5:29 is going to be 2 hours and 31 minutes before low tide. So the water will reach 3.5 meters above the ocean floor, again 2 hours and 31 minutes after low tide. So 8 plus 2 hours and 31 minutes is going to take us to 10:31 a.m. So that's a trig functions application problem. Now go and practice.